What is the geography of water supply and demand? Climate. This determines global water distribution, annual and seasonal rainfall and snowfall. Rivers. These transfer surface water across continents. Geology. This controls aquifer distribution. Blue water flow. This is water in rivers and aquifers. Green water flow. This is river stored underground. Only 1% of Earth's total water resources are easily accessible as surface water. This means that it is a finite resource. Water vulnerable. This is defined as water being under 2,500 meter cubed per person per year. Water stress. This is defined as being under 1,700 meter cubes per person per year. Water scarcity. This is defined as under 1,000 meter cubed per person per year. Physical scarcity, when 75% of a country's or region's river flows are used. Economic scarcity. This is development of blue water flows is limited by human and financial capabilities. India. Case study. 1. It has a monsoon climate due to the movement of ITCZ and has little supply from December through to May, and is a monsoon from June through to October. 2. It has a changing discharge in the Indus, Ganges and Brahmaputra, and this varies due to monsoon and the melting of snow in Himalayas. Lots of water in the north, but less in the south. 3. Geology. Aquifers in the north mean that they have a good water supply. 4. Desertification in Beijing is happening at a rapid rate. California case study. The mountain chains are parallel to the coast, meaning this prevents moisture reaching inland. Moist air from Pacific is forced upwards by mountains. It cools and condenses and forms relief rainfall and snow at high altitudes. Up to 500 millimeters of rainfall in the coastal zone, no wider than 250 kilometers. Death Valley and the Mojave Desert have less than 100 millimeters of rainfall due to the rain shadow effect. Some water infiltrates the surface layer, percolates through rocks, and becomes groundwater. Nearly a third of fresh water comes from aquifers. Major rivers are fed by snowmelt from Sierra Nevada mountains. The El Niño means that there is above average runoff and flooding in southwest. La Niña brings drought. In recent years, extended droughts mean groundwater and surface storage water levels have decreased. Agriculture. This uses 69% of world's water per year freshwater supply. Some forms are more water costly than others. 17% of global area is used for crops is irrigated. While water storage and irrigation systems do increase agriculture productivity, they can also be wasteful of water. Poor management of systems means that evaporation problems, seepage, salinization, and fertilizer pollution. Industry. This uses 21% of the world's per year freshwater supply, rapidly increasing due to NICs, China and India. HEP uses large amounts of water but is available to others once it has passed through turbines. Industry is more efficient than agriculture, but there are exceptions. Paper production is one of the highest users. Industry also causes water pollution problems. Domestic use. This is the smallest category of consumption and uses only 10% but varies country to country. Most MEDCs need at least 100,000 litres per person per year, but most Africans have less than 50,000 litres. Global demand doubles every 20 years, and the quality of water also varies considerably. Supply. This comes from two sources. Surface water, rivers, lakes, reservoirs, and megadams. Aquifers. Sole source of drinking water for a quarter of the world's population. Water from aquifers is being extracted faster than it is being replaced. Long-term costs of over-extraction are dwindling supplies. India. India has 4% of the world's freshwater, but 16% of its population. Demand is predicted to exceed supply by 2020, whereas urban demand is set to double, and industrial is set to triple. Hydrologists calculate that 43% of precipitation never reaches rivers or aquifers, and water tables are decreasing rapidly as 21 million wells extract water. China case study. China has 8% of the world's freshwater but 22% of its population. Two-thirds of Chinese cities don't have enough water all year round, and national water supplies are likely to reach stress levels by 2030. Irrigation is also used to produce 70% of food, mostly where the Yellow River and major aquifers are running dry. There are huge engineering projects, meaning that they will transfer vital water to area from water-rich south. Pollution, over-extraction and saltwater incursion. Pollution. Sewage disposal in LEDCs is expected to cause 135 million deaths by 2020. Chemical fertilizers contaminate the groundwater, rivers and water supplies. Each year, the world generates 400 billion tons of industrial waste. Heavy metals can become concentrated. Big dams trap sediment in reservoirs, meaning that it reduces the floodplain fertility and nutrient flow from rivers and seas. Over-extraction. Worldwide, water is being extracted from aquifers faster than it is being replaced, and in arid areas, rainfall can never recharge underground stores. Saltwater incursion. Removal of fresh water from aquifers in coastal areas can upset the natural balance of saline and fresh groundwater, meaning that this results in saltwater incursion. Water Poverty Index. In 2002, the British Centre for Ecology and Hydrology published its first WPI. Resources. This is the quantity and quality of surface and groundwater per person. Access. This is the time and distance of obtaining sufficient safe water. Capacity. This is how well water is managed in the community. Use. How economically water is used in home, agriculture and industry. Environment. This is ecological sustainability. Each is scored out of 20 to give a possible maximum score of 100. Poverty. Poverty and water poverty are part of a wider equation. Lack of water. This reduces attempts to eliminate poverty and encourage development. Improved water supply, sanitation. This means that it increases food production, promotes better health and higher well-being standards. Water wealth in developed countries means that cheap water, irrigation energy and economic growth can occur. Water dubbed by some as lubricant of development. Contrasting water extremes, case study. Canada and Ethiopia are at two extremes of water development spectrum. Water consumption in Canada is 800 litres per person per day. Water consumption in Ethiopia is 1 litre per person per day. Problems for Canada: rising water bills, leakages, and problems for Ethiopia: water shortages, pollution, and disease risk. WPI: Canada's is 78 and Ethiopia's is 45. Access to improved water percentage: Canada is 100 and Ethiopia is 24. Access to improved sanitation: the percentage for Canada is 100 and for Ethiopia is 12. Varying water prices around the world. As demand outstrips supply, water costs are set to rise. Price of fresh water depends on transport costs and level of demand. Californian cities obtain water from the Colorado Basin, meaning this is energy expensive as they have to pump the water. Australia, this peaked at nearly 75 cents per metre cubed in 2006 and increased as a result of drought. In India, water scarcity forced some farmers to sell abstracted water rather than keep for irrigation. What are the potential implications of an increasingly water-insecure world? Aral Sea case study. Once the world's fourth largest inland sea, steadily shrinking since the 1960s. In the late 50s, the government Soviet diverted water from rivers Amu and Syr Darya for irrigation and agriculture. By 2007, this declined to just 10% of its original size and split into several lakes, and the level fell to just 40 meters. This is an environmental catastrophe. There are several stakeholders. Former Soviet government. These created irrigation scheme to develop fruit and cotton farms and create jobs for millions. Fishing community. This used to employ 60,000 but has collapsed. Unemployment and economic hardship are everywhere. Local residents. Health problems from wind-blown salt dust from dried out seabed, drinking water from polluted weapons testing. Industrial products. Pesticide and fertilizer runoff. Infant mortality among the highest rates. Scientists. Only very few of original mammal, bird and fish species remain, and the climate has changed. International economists. The people in the region may not be able to feed themselves as land is now infertile. Up to 10 million may be forced to migrate. Water engineers. Inspection revealed water canals for irrigation were poorly built, allowing water to leak out or evaporate. Water conflicts. When demand for water overtakes supply and several stakeholders want to use the same resource, this creates the potential for conflict. Competing demands irrigation, water, power generation, domestic use, recreation, conservation, these can also create conflict. Reports suggest around 300 potential conflicts as rivers, lakes and aquifers struggle to provide sufficient water. The Middle East water conflicts. The Middle East has low seasonal rainfall and a growing population, and this is the main root cause of water conflicts. Western part. They are in dispute over shrinking water supplies. Security of water supplies were not the cause of the 1967 Arab-Israeli War, but were a contributor. Water in the region comes mainly from River Jordan and three important aquifers. Division of resources between states is an ongoing challenge. The eastern part. Turkey plans a build of dams to store and use water in headwaters of Tigris and Euphrates rivers. This is strongly opposed by Syria and Iraq, where dwindling water supplies threaten economic development and hold back food production. Tensions between India and Bangladesh. Case study. Most of the 2,500 kilometre Ganges River flows through India, but the last part flows through Bangladesh. In 1974, India opened Farakka Barrage, 11 kilometres from Bangladesh border. A series of dams divert water for irrigation, and the largest cities use river to carry wastewater. Bangladesh is a double loser, as it is deprived of much needed water and has to suffer the effects of India's pollution. Although an agreement was signed in 1990 for fair use, India is very much in control of the situation. Bangladesh has many grievances, including reduced river flow affecting irrigation and food production. The fish stock and industry is in decline. Navigation and waterborne trade are harder because of low river levels. Increased salinisation, delta eroding as there is less silt being carried on depositors, and seawater incursion increases as delta dries out. Water geopolitics. As water resources are more significant, more treaties are negotiated. This is called water diplomacy. Helsinki rules. The criteria for water sharing should be based upon natural factors, rainfall amounts, water sources, drainage basin sharing, social and economic needs, population size, development and welfare, downstream impacts, restricting flow, lowering water tables and pollution, dependency, are alternative water sources available to the country, prior use, tricky question of existing and potential use. Efficiency, avoiding waste and mismanagement of water. In reality, agreements are rarely equitable as countries with the greatest power gets the better deal. The Colorado River case study. The basin of river is the most used irrigation source in the USA. Involves more than 10 major dams to provide for 30 million people. Initial agreements allocated the largest water amount to California, the largest population, and considerable political power, but since been reduced by new development and legal challenges. The 20s saw the highest rainfall and water surpluses. As population increases and water availability decreases, growing challenges for the states and players involved, stakeholders. Farmers. Agriculture receives 80% water allocation, and to increase agricultural development, the federal government supplied water at low cost. Most of the water was, however, wasted in flood irrigation and inappropriate crop choices. City dwellers. Southwest and urbanized California accused of using future water for other states. As a 5-year drought and population continues to rise, conflict has become angrier. Arizona took full share of water for its states in 2007. U.S. federal government. Under pressure to change water allocations, water issues could affect U.S.-Mexico relations. Environmentalists and recreationalists. Recorded development of lakes is of increasing concern to environmental groups who would prefer the levels of recreational activity in wetland wilderness areas. Indigenous groups. Natives have water rights based on treaties agreements made between tribes and federal government in 1880s. The river is used so heavily that it no longer reaches the sea, as 90% is extracted before the river reaches Mexico. Wetlands once in deltas are now barren mudflats, and the delta has reduced in size as water and sediment is retained by dams in Colorado. Measures to control Colorado River, prevent floods, generate electricity, provide domestic water were engineering marvel at time of construction, but now a costly, inefficient and environmentally damaging operation. What are the possible conflicts and solutions to increasing demands for water? Different water futures. Business as usual. Water changes for 2025. Water scarcity decrease. Food production. Water consumption increases 50%. Household use increases 70%. Industrial demand increases in developing countries. Wider impacts. Developing countries reliant on food imports experience increased hunger and malnutrition. Sub-Saharan Africa grain imports more than triple. USA, China, India, Egypt, and North Africa pump water faster than aquifers can recharge. Water crisis. Water changes by 2025. Global water consumption increases further, most on irrigation. Worldwide demand for domestic use decreases. Industrial demand increases 33% over business as usual levels, yet output remains the same. Wider impacts. Food production decreases, whereas food prices increase. Malnutrition and food insecurity increase in developing countries. Key aquifers in China and India will fail, and water conflict will increase. Sustainable water. Water changes by 2025. Global consumption and industrial consumption will have to fall. Environmental flows could be increased. Global rain-fed crop yields will increase due to water harvesting improvements and sustainable farming. Agricultural and household water prices will be 2 times developed and 3 times in developing. Wider impacts. Food production increases and prices decrease. There will be need for investment in crop research, technology and water management. Governments will delegate farm management to community groups. Three Gorges Dam case study. Along the Yangtze River, it is the world's largest hydroelectric scheme. Given China's current 70% reliance on coal power stations, this sees HEP as a clean energy to support rapid industrial growth. Social and environmental costs are apparent before economic benefits are reaped. Benefits: 18,000 megawatts of water regenerated electricity save 50 millions of coal each year. Supply region responsible for 22% of the GDP. The flood protection will save lives and cut financial losses caused by floods. Navigational improvements will mean that it will open interior region to development. The costs: waters will drown 100,000 hectares of arable land and 1,500 factories. About 1.9 million people will be displaced from homes and lose land. Dam failure, earthquakes, heavy rain will bring risks. Ecological impacts on fisheries, biodiversity and habitats. Pollution will increase as abandoned mines and factories flood. Important heritage sites will be lost. The river is the fifth largest sediment load, meaning it damages turbines, trapped sediment raises water levels, and reduces soil fertility. Snowy Mountains case study. This is the largest engineering project and among the most complex HEP schemes. The scheme collects and diverts water to be used in power stations to create electricity. Water flows west to Murray and Murrumbidgee rivers for farm irrigation and communities in New South Wales, Victoria and South Australia. It took 5 years to complete. Negative impacts occurred. This was the creation of storage lakes destroyed valuable habitats of wildlife, and some river flow has fallen to 1% of its original discharge. Groundwater overdraft and salinisation problems occur from low flow and irrigation affected farming. Political fallout has forced governments to restore some flow in Surrey River and invest in water-saving projects. The aim is to protect farmers from worst water storage effects. Turkey to Israel case study. Israel's hydrological service has warned country's reserves are severely stretched as aquifers are salinised and levels of Sea of Galilee fall. The demand has reached 1.5 billion metre cubed per year. Turkey has surplus water which could be taken from the Mangaret River and sold to Israel. 2001. Countries plan undersea pipeline via North Cyprus. 2002. Israel is in talks with Turkey to import 50 million metre cubes each year. 2004. Syria objects Turkish plans. 2005. Discussion about possible pipeline again. 2006. Idea scrapped from terrorism fears and costs of desalinating water fall. 2007. Turkey proposes overland pipeline to link Middle Eastern states. 2008. Official figures suggest Turkey is experiencing drought and water shortages, and this is a result of global warming and poor management. River Kissimmee case study. Severe flooding in the 1940s around the local area caused moral panic. This resulted in an attempt to straighten the river's channel away from local villages. The water entering the basin was controlled by storage lakes. Impacts: large recharge in Miami's groundwater aquifers, salinization of water supplies, less water flow, then was 0.40 meters per sec, now 0.05. 92% loss in birds, and eutrophication from nutrients. 1975. Restoration Act passed. 11,000 hectares were restored to wetland. Levees removed and meanders restored. Some parts of the canal remain to protect settlements, trying to allow river to return to seasonal flow. Aral Sea restoration case study. Breaking up of Soviet Union to northern part of sea in Kazakhstan and southern part in Uzbekistan. 2007, Kazakhstan secured a $176 million loan from World Bank to help save north part of the sea. Kazakhstan used an earlier $68 million loan to build a dam to split the sea in two parts. Claims that the northern sea is already filling up as Sea Daria is flowing into it. New loan used to build second dam to return flow to port of Aralsk. Fishermen are already back in boats, rain has returned, and future is no longer hopeless. However, it has not solved the south problems. The sea is still shrinking and may be too late to save it. This part of the world where sensitive water development could easily trigger conflict. Waters of Amu Darya should be flowing into South Sea and needed for vital cotton cash crop of Uzbekistan. Role of water aid. This works in 17 countries. Ethiopia. It has provided mobile toilets in Addis Ababa. It helps keep the environment clean and provides employment for the homeless. Uganda. In Uganda they are educating to maintain water sources. Locals are taught how to construct latrines so the water is not infected. Ghana. Over 5 million have no access to clean water. WaterAid provided tools and education for wells, meaning that there was less time fetching water and less illness. Conserving water. Developing sustainable water conservation strategies are vital in an attempt to combat climate change. Agriculture. Sprinkler and surface flood irrigation are steadily being replaced by modern spray technology and advanced drip irrigation, which uses less water. Industrial. This wastewater is frequently recycled using filters and chemicals. Domestic. Compulsory provision of water meters makes consumers more careful of water use. Water harvesting via rain butts is an important strategy. The number of sustainable water projects developed in low-income countries to provide villages with accessible clean water and to conserve water. Desalination. This is the process of removing salt from water. It is a costly process, but water scarcity increases means some countries have no choice. There are two methods. Reverse osmosis. This is the diffusion of water from high salt content side to low salt content side, and collection tanks and transfer pumps are required. The second is thermal. Heating the water solution and gathering pure water when vapour cools and condensation occurs.